Today's lesson is drawing simple covalent molecules. When you are presented with a covalent molecule and tasked with drawing it, the first thing you want to do is look at every individual element and draw out the Lewis dot diagram for the neutral version of that element. So for water, we have H looks like this, oxygen like this, carbon, oxygen again, nitrogen, and hydrogen. Now, we have a choice. Once we know what all of the elements look like in their neutral Lewis dot, we have to spot the element in each compound that has the greatest number of unpaired electrons. So, electrons in a Lewis dot diagram that are by themselves. H has 1, O has 2. So in oxygen, O is going to go in the middle. Carbon has 4, oxygen has 2, so carbon is going to go in the middle. Nitrogen has 3, hydrogen has 1, nitrogen goes in the middle. Now, when we have elements that have only one electron that is existing or one electron that is by itself, it's very easy to complete the drawing. You're going to take that element and draw it so that its lone electron is facing the lone electron of the central atom. Remember, in water there are 2 hydrogens, so each one we're going to draw with its lone electron facing the lone electron of the central atom. We're also going to do that for NH3 over here. Now, once you have this lined up, all single electrons that are facing each other are going to bond and form a covalent bond. And how we represent covalent bonds is a line that connects those 2 electrons. So if you were tasked with drawing the covalent, the Lewis dot structure for water, this is what it looks like. This is what nitrogen looks like. Once you get to something like this, though, there's a little subtlety that happens. You see that carbon has 4 single electrons, right? All of those single electrons must form a bond. So that means that carbon can form 4 bonds, and oxygen can form 2. Well, there's 1 carbon, and there's 2 oxygens, so I'm going to draw carbon with 4 bonds and oxygen with 2. These double lines between elements are called double bonds. The highest number of bond is a triple bond. All right, and let's take a look at one compound that has triple bonds. A famous compound with triple bonds is HCN, hydrogen cyanide. Right? This is the chemical that spies would take, right, to avoid capture, right? And it has a very interesting shape. H has 1 electron, carbon has 4, and nitrogen has 5. But when we're deciding which element goes in the center, all we care about is the number of single electrons. H has 1, carbon has 4, nitrogen has 3. So carbon is going to go in the middle. Like we said before, it's easy to conceptualize when we have only one dot to deal with. All right, so we're just going to draw H facing C, and we're going to draw a line connecting it. Now on the other side, we have N, right? And we know that N has 3 electrons that are by itself. So N can form 3 bonds. There can be 3 lines coming off of N. Carbon has 4, and it can form 4 bonds. But it has already formed 1 with hydrogen. So, to fill up those 4 bonds, it's going to use all 3 that it has left to bond with nitrogen. Okay? Another way to picture this, if you're having trouble visualizing, is again, we're going to draw single electrons facing each other and connect them. Alright, a cleaner way to make this look, and the way you will see in textbooks, however, is just this. This is called a triple bond. Hopefully this helps in drawing simple covalent molecules and getting a hand for your start at drawing.